Hi everyone. Now let us see two PYQs on Newton's recurrence formula in quadratic equations. See one PYQ. Let Pn is equal to alpha to the power of n plus beta to the power of n. N belongs to capital N. If P10 is equal to 123, P9 is equal to 76, P8 is equal to 47 and P1 is equal to 1, then the quadratic equation having roots 1 by alpha and 1 by beta is. This problem was given on April 2nd, 2025, shift 1. So what is Newton's recurrence formula? If alpha comma beta are the roots of the quadratic equation, ax square plus bx plus c is equal to 0 and Sn is equal to alpha to the power of n plus beta to the power of n belongs to capital N. Then we can write a into Sn plus b into Sn minus 1 plus c into Sn minus 2 is equal to 0. That is called Newton's formula. So in place of x square you can substitute Sn, in place of x you can substitute Sn minus 1, say plus c into 1, c written same, in place of 1 write Sn minus 2. This formula also valid if Sn is equal to alpha to the power of n minus beta to the power of n is there. Had given proofs of both the results at the end of the practicing problems. So if you are interested, you can go through them. Now let us see the solution. So in the formula I told the notation Sn, but in the problem he had given Pn notation. So I am continuing with only Pn notation. So he had given Pn is equal to alpha to the power of n plus beta to the power of n. He had given the value for P1. Substitute n is equal to 1. Therefore, I can say P1 becomes alpha plus beta. But he had given the value of P1 is 1. Now we know sum of the roots of the quadratic equation. So if alpha, beta are the roots of the quadratic equation, what is the formula? Quadratic equation can be written as x square minus sum of the roots into x plus product of the roots is equal to 0. X square minus sum of the roots into x plus product of the roots is equal to 0. So let us write x square term same. For alpha plus beta I am writing 1 into x. Product of the roots is not known. Let us write k. There alpha beta is represented with constant k. So in this quadratic equation just only one unknown k is there. We have to calculate k. To find k he had given P10, also P9, also he had given P8. Let us use Newton's formula. In place of x square I am substituting Pn minus in place of x I am substituting Pn minus 1, k into 1. In place of 1 I am substituting Pn minus 2, that is the Newton's formula is equal to 0. So to find constant k I am substituting n is equal to 10. P10 minus P9 plus k into P8 is equal to 0. He had given the value of P10, that is 123. The value of P9 76 plus k into the value of P8, that is 47 substituted. So I want to calculate k. Therefore 47k is equal to 123 minus 76, that is 47. Taken to right side, it will become minus 47. So that value of k becomes minus 1. So constant term in the quadratic equation was calculated. Therefore, what is the quadratic equation now? Quadratic equation f of x is equal to x square minus x constant term is minus 1 is equal to 0. So I wrote the quadratic equation whose roots are alpha and beta. But in the problem he is asking quadratic equation whose roots are 1 by alpha, 1 by beta. You know this formula. If alpha comma beta are the roots of quadratic equation, f of x is equal to 0. To write down quadratic equation whose roots are 1 by alpha, 1 by beta. In the given quadratic equation, x must be replaced it with 1 by x. By using that formula, I can say required quadratic equation. So required quadratic equation, I can say f of 1 by x is equal to 0. So in the given quadratic equation, replace x with 1 by x. So it will become 1 by x square minus 1 by x minus 1 is equal to 0. Taking LCM, 1 minus x square is equal to 0. Cancelling minus sign, x square plus x minus 1 is equal to 0. So this is the quadratic equation whose roots are 1 by alpha and 1 by beta. See which option is correct option. So you can see option B is the correct option. See one more PYQ. If alpha comma beta are the roots of the equation x square minus x minus 1 is equal to 0 and Sn is equal to 2023 alpha to the power of n plus 2024 beta to the power of n, then so we have to calculate the relation connecting S12, S11, S10. This problem was given on January 27, 2024, shift 1. See, it is slightly different as compared to the previous model. So just I am writing the given quadratic equation. Given quadratic equation, x square minus x minus 1 is equal to 0. That is the given quadratic equation. So alpha is the root of the quadratic equation. I am substituting x is equal to alpha. So alpha is the root of the equation. It will satisfy the quadratic equation. Therefore, I can say that alpha square minus alpha minus 1 is equal to 0, or alpha square can be written as alpha plus 1. Alpha square is equal to alpha plus 1. Multiply both sides with alpha to the power of n minus 2. Therefore, I can say alpha to the power of n must be equal to alpha to the power of n minus 1 plus alpha to the power of n minus 2. Just I multiplied both sides with alpha to the power of n minus 2. So I expressed alpha to the power of n in terms of alpha to the power of n minus 1, alpha to the power of n minus 2. So beta also root of the quadratic equation. Therefore, similarly I can say beta to the power of n can be written as beta to the power of n minus 1 plus beta to the power of n minus 2. So beta to the power of n expressed in terms of beta to the power of n minus 1, beta to the power of n minus 2. So what he had given SNC there? There SN he had given 2023 alpha to the power of n plus 2024 beta to the power of n. I want to express Sn in terms of Sn minus 1 and Sn minus 2. Let us write Sn is equal to 2023 is written same. So in place of alpha to the power of n, I am substituting first equation. That is alpha to the power of n minus 1 plus alpha to the power of n minus 2. From first equation, for alpha to the power of n, I substituted. Similarly, 2024 is written same. From second equation, beta to the power of n can be written as beta to the power of n minus 1 plus beta to the power of n minus 2. So let us rearrange terms. Sn is equal to 2023 alpha to the power of n minus 1, 2024 beta to the power of n minus 1. First term in the first bracket, first term in the second bracket, they were kept in one bracket. Similarly, let us write 2023 alpha to the power of n minus 2 plus 2024 beta to the power of n minus 2 in the next bracket. 2023 alpha to the power of n minus 1 plus 2024 beta to the power of n minus 1. What is SNC there? If the given expression is 2023 alpha to the power of n plus 2024 beta to the power of n, that is represented with Sn. So in place of n we are having n minus 1. So according to the given representation, this bracket is represented with Sn minus 1. Just in place of n, here we are having n minus 2. Therefore that second bracket is represented with Sn minus 2. So I wrote the relation connecting Sn, Sn minus 1, Sn minus 2. So in the given options he had given the relation connecting S12, S11, S10. So I am substituting n is equal to 12. Therefore I can say S12 is equal to S11 plus S10. So this is the relation connecting S12, S11, S10. See now which option is the correct option. So I can say option B is the correct option.